Hello everyone, this is JAHNAVI. I am pursuing my BTech second year in KL University. Now I am going to explain about the DES algorithm in cryptography. So coming to cryptography, here the ciphers are classified into two types, classical type and modern type. Under classical we have two types of techniques, substitution techniques and transposition techniques. Substitution techniques like K-cipher, transposition techniques like column transposition techniques. Under modern, we have two types of keys, which is symmetric and another one is asymmetric. Under symmetric key, again we have two types, block cipher and stream cipher. So now I am going to explain about the algorithm DES, which is under block cipher. So in block cipher also we have AES algorithm, DES and 3DES. And under stream cipher we have RC4 and SEAL. So and coming to asymmetric key, we have RSA, DSA and Hammond algorithm. So, so now in cryptography, under the modern using symmetric key at block cipher, I am going to explain about the DES algorithm. So before going to the steps involved in DES, so in DES we have two types. One is DES algorithm, which is having 64 bits, and the other one is SDES, which is done by 8 bits. So first I will explain the DES algorithm. Later, I will explain the SDES and the differences between those. Coming to DES. So, DES consists of block size as 64 bits and the number of rounds in DES is 16 rounds. So, for each round, we are going to see the operation, what will happen. The size of the key is 64 and each round has distinct subkeys which are 16, like for each round, like we are having 16 rounds, right? So for each round we are going to use that, so that's why we have 16 different subkeys. So the subkey size is 48 bits. So the ciphertext, finally the ciphertext is also 64 bits as an output. So this is the algorithm diagram of DES. Before going to explain this algorithm, I am going to tell 3 points which must be remembered by us. So one is permutative choice. The first one is permutative choice, and the second one is expansion permutation, and the third one is S-box. So in whenever the permutative choice or expansion permutation or X-box operations done, we have to do this calculation. Like for permutation choice, we have to subtract 8 bits for the existing bits, and for expansion permutation we have to add 16 bits for the existing one, and for S-box we have to subtract 16 bits for the existing. So these are the points we have to remember for the operations we have to do in this algorithm. So firstly we are passing plain text as 64 bits to the initial permutation. Initial permutation which performs the operation and pass again 64 bits to the round 1. Here I already explained about the rounds. We have 16 rounds in 64 bits plain when we are using 64-bit plain text. So the round operation will be explained later by me. Coming to this side, we are passing 64-bit key to the permitted choice. Permitted choice means which we have to do the operation as minus 8 bits. So after decreasing the 8 bits, we will get 56 bits. Then next left shift will be done. After the left circular shift done, we will pass again 56 bits. Then permuted choice, which means we already done as minus 8, and then we will get the key size as 48 bit. Here in the before we also saw that key size is 64 bit, right? So this is the 48 bit key we are passing to the round 1. So in the round 1 we are doing one operation, later I will be explained. So after these 16 rounds we are dividing the 64 bit into 32. After we have to swap them, then again we are passing that to 64 bits as into the initial permutation, which is the inverse of the initial permutation, and then we will finally get the 64-bit ciphertext. So now I am going to explain about this round function. So this is the round function in DES algorithm. So here, as you can see, we are taking the round function input as 64-bit, right? Here the 64 bits here the 64 bits are divided into 32 bits and 32 bits, and we can see 28 bits and 28 bits in the right side. Here the 56 bits we are passing to the next left circular shift. So these 56 bits are divided into 28 bits and 28 bits. So we are taking these as Li minus 1, Ri minus 1. So when the Ri minus 1 is going to enter into the expansion permutation, at starting I already said when the expansion permutation operation done, we have to add 16 bits. So by adding 16 bits to the 32 bits, we get 48 bits. Then after coming to here, we are performing left shift operations on both sides and send them to the output and the permutation contraction. After permutation choice, we know that we have to subtract minus 8 bits. So we get the key as 48 bit. After key generation, we have to do XOR operation with these two 48 bits. Then we can get the output as 48 bit. Then we have to do an SPOX operation which can decrease the 16 bits so that the permutation operation will done. 32 bits will be done an XOR operation and the final RI output. So the initial 32 bits and the final 32 bits done an XOR operation, and then finally we will get RA. So this initial right side Ri minus 1 will be taken as input for the second round. So this is the process entirely done by the round function. So this is the process we have to do in each and every round. So in DES we have 16 rounds, so we have to do this function 16 times. So this is DES algorithm. So coming to SDS algorithm, SDS consists of 8 bits and the ciphertext as 8 bits, which call output. In SDS algorithm, there are three parts, which is one is encryption and this is called as key generation and this is decryption. So first we are passing 8-bit plain text to the IP in the sense inverse permutation, and then we are doing function key. Then we have to swap and then again we are going to do key function with the key 2 generator. Here we are doing with key 1 generation. So finally we have to do IP inverse, then we will get the encrypted ciphertext. So same as usual for the decryption also, but it is the reverse case of encryption. So we have to do the IP inverse, then F key generation, then swap and again function. So finally IP. So we will get the cipher decrypted text. So in key generation we are having P10, P8. So by these two, firstly we have to take P10 and then do operation as circular shift, left circular shift. After that we have to do the after that we have to do operation with P8 so that the P8 after that P10 shift P8 we can get key 1. So that key 1 will be generated to both encryptor and decryptor first function. Then also from this shift we have to do again an P8 operation so that the key 2 will be generated. So this is the diagram for SDES algorithm. So now so this is the function will be done in SDES. This is the inside operation done by the function key in SDES algorithm. So while comparing to DES and SDES, we will get that SDES is an 8-bit block and DES is a 64-bit, as I already said. So these are the things we have to be noted. So that's all, guys. Thank you.